Hello people, welcome back to my channel. So in today's video, we'll be seeing a Python demonstration of the internal cluster validity measure, that is the silhouette coefficient. Now, I have already made a video way back regarding the silhouette coefficient, but that did not include any solved example, or it didn't give you much idea of how do we actually calculate the silhouette coefficient for single point for one cluster and for the entire clustering. So there are three different things over which you calculate the silhouette coefficient. So just by looking at the formulas and looking at the algorithm, you won't get the idea of how difficult it is to calculate the silhouette coefficient on a pen and paper, but I have did that activity, and also I'll demonstrate you how you can do the Python level translation of those computations. So for that, these are the steps for calculating the silhouette coefficient. So you are watching this video for the first time and you don't know what is silhouette coefficient, why it is used, and its purpose, I suggest you to watch the older video of silhouette coefficient. It will give you a brief idea of why silhouette coefficient is actually used in cluster validity, and then you come back to this video and watch uh, like how you actually implement it. Okay, so what we actually require are the raw materials for computing the silhouette coefficient. So first we need the distance matrix. So distance matrix is not only used in silhouette but in dbscan density based clustering. So there also we make use of the dbscan, that is the distance matrix. So here also will require distance matrix, but when we do it on paper, it will take some time, but here there is a short way, or just by writing 2 or 3 lines of code you can actually get the entire distance matrix based upon the Euclidean. And the uh, cherry on the cake is like you can just shift around with just one parameter, so it will calculate the distance measure or function as Euclidean or Manhattan or any other distance function as you wish. Okay, so that is done with the help of one important library that will come across down the line when we actually look at that portion. So to calculate the silhouette coefficient of a data point x, we calculate that is a, which is the average distance to the points in its own cluster. So say xi is a point, and the cluster to which xi belongs, we first calculate the distances to that point and then we average it out. That gives us the a value. Then we have b, so that is the average distance of points in the nearest cluster. Okay, so when we have those a and b values, we basically calculate the silhouette of x of that point by calculating b minus a upon max of ab. So this is the formula. Or the simpler way is like you can have three ranges, like if a is less than b, you can use 1 minus a upon b, or if a is greater than b, you can use b upon a minus 1, or if both are equal, that means silhouette is 0. So you can use either of the formula, both are equivalent, that is either this one or this one. Okay, and then you have to repeat for all the points which are there in your data set. So it becomes a very herculean task when you have a huge number of data points. So currently in this example, what we'll be having is we will have a set of 14 different points for our problem, or for demonstrating the silhouette coefficient. So first of all, we'll have some libraries, that is from SciPy spatial distance. We are importing two functions or two libraries, that is p distance and square form. So these two things will be majorly used for calculating the Euclidean distance, that is a distance matrix. Then from sklearn matrix, we import a pairwise distance. So this is another library, okay, and we use the NumPy and pandas. Okay, so this is by default for any activity, Python activity. So this is how it looks like. So let me give you an idea of what I did on pen and paper. So these are the coordinates of the points. We have points x, y, and this is my cluster. So we have a data set which looks something like this, or we have to reproduce this in Python. Let's see how we can do that. And say I have 15 points, not 14, that is 0 to 14. And what I basically do is I'll just put it into labels. So 0, 1, 2, 3 will belong to cluster C1. Okay, so I'm basically putting a dimension glyph, that is a 0, then a cross marker for C3 and a triangle for C2. Okay, so this is how my data set is. Now let's see how we can build that in Python. So this is my data. So I have the x values and I have the y values. So entire thing I'm storing it in a dictionary, and the clusters. So these are nothing but the things which you can see on the columns. Okay, and we'll just invoke the pd dot data frame, and what you obtain is this particular data frame which you can see here. Okay, so the data points which you see, that is by default given as an index. When you create a data frame, you need not worry about from where we can put that, or if you manually put as index 1, then also you'll have this indexes. So it's better not to put that. Python will give you whenever you create the data frame. Okay, so since we have represented our data set, uh, now it's time to calculate the distance matrix. So like I said, we require two libraries, that is pdist and square form. So that will be majorly using throughout for calculating the Euclidean distance or the distance matrix. So this is how it is used. So you make use of the pdist function, and inside the pdist function you pass this data frame which consists of your x and y, that is these two columns, and you pass a metric. So this is a parameter which is actually present in pdist, and you set the value as Euclidean. So it has the ability to calculate Euclidean distances for all the points which are present in your data frame among x and y. So you do on pen and paper, you calculate the distance, all the diagonals will be 0 and the off diagonals will be symmetric. So that's how the distance matrix looks like. And then you have to pass that result in a function called as square form. So square form is another function where it will give you a symmetric distance matrix. So all the upper triangle and lower triangle will be equal. That is symmetric. So let's go ahead and just run this, and this is how what you obtain as your distance matrix. So you can cross check, like all the diagonals here you can see everything is 0 and the off diagonals are symmetric. So for all the 15 points which are there in your data set, you get this in this way by means of SciPy. So this is done with the help of this SciPy package, and from that we are making use of the p distance square form. So that is for calculating the distance matrix. Now our distance matrix is done. Now we need to calculate the silhouette coefficient for each of the data point. So every data point, consider like 0 is one data point, 1 is one data point, 2 is one data point, 3, 4, 5. Each of these has its x and y coordinates. So you have to calculate it. So how do you calculate the distance or the a values? So let me give you this thing. So we have done the step one, that is distance matrix calculation. So in order to calculate the A value, you have to calculate the average distance to the points in its own cluster. So if we look at the first point, that is 0 0.1 and 2, all these three belongs to cluster C1. Okay, so now we have to find the distances to the points of 0 to 1, 0 to 2, 1 to 0, 1 to 2, 2 to 1, 2 to 0. So that gives you the distance values. So the distance function everywhere will be using is Euclidean metric, so there is no doubt in that. Okay, and so these are the distances, and then we take out the average of all the distance, that is we get this value as 1.207. Okay, so now what we do is we take in this way, that is distance of 0 to 1 and 0 to 2, and then we take the average, then 1 to 0, 1 to 2, you take the average, 2 to 0, 2 to 1, you take the average. So when we actually plot that thing, it actually looks like in this way. So this is how it looks like. So the average distance for this particular point, 1.207, for this it is 1, for 2 it is 1.207. So it is in this way you calculate. So first you calculate the average distance of all the points within that cluster to it belongs to. So now similarly, for the other cluster which you have, that is C3 cluster, that is with a cross mark which I have given. So you calculate the same thing in this way. So how do you do that thing? So that is done basically with the help of uh, this particular construct. So here also I am passing a dictionary, and that dictionary I am converting it into a data frame, and that is my A values. And then I concat this to my original parent data frame along the rows. That's why axis is equal to 1, and this values I manually computed, that is 1.207, 1, 1.207. Okay, that is this values. So I get those values, I put it into this value, and I generate this particular A values. Now second step is to calculate B, that is average distance to points in the nearest cluster. So the thing what I said there, that is in this particular step, that is 1.2071, and this thing how I got is like I calculated in this way. So distance between 0 to 1, 0 to 2, and its average, 1 to 0, 1 to 2, its average. So this is how it is calculated for all the other points, like in 3 to 4, 3 to 5, 3 to 6, 3 to 7, 3 to 8, then 4 to 3, 4 to 5, 4 to 6, 4 to 7. In this way you calculate all the individual values, and then you take out the average. So likewise you have to do for all the points which are present in that cluster. So now you can imagine how difficult or how time consuming is this calculation when you do this on paper. But this computation becomes easier when you use a distance metric as Manhattan distance, because there you need to just to calculate the absolute values. So there it becomes easier for calculation. So this is how you do for the other points as well. So this is how the computation, just a graphical way of how do we calculate this. So these are all the A values that we get, and that's what I put it into this particular column, that is my A. So A values will be there for each and every point. That is the takeaway. Okay. Next, step 2 is to calculate the B value. Now it is the average distance of the points in the nearest cluster. So how do you calculate that? So this is how you do. So let me give you this overview. So b value is calculated, say for example for a point 1 4. Now 1 4 we know that it belongs to uh, the cluster 0. So from here we got like 1 4 belong to this particular glyph. This is 0, and cross and triangle are called as dimension glyphs. So I'm giving this as a class, that is 0. So since it belongs to that, now we have to find the distances of that point in that cluster to the points which are there in the cross cluster. Okay, so these are my distances that I found to all the points which are there in the other cluster. Okay, and these are the distances to the points that I found in the C2 cluster or the triangle which I represent, and I take out the averages of this. And then what we do is we take the minimum of this two. So that's nothing but 3.89, and we say that the this particular cluster, that is the C3 one, with the cross marker, that is the nearest one to that particular cluster. Similarly, you do for all the other points which are there in the cross cluster and in the triangle cluster, or in the C2 C1 C2 C3 clusters, and you do in the same way. So that's what I wrote here. So how do you do that? So here I'm basically calculating a series, not a data frame. There is a difference between data frame and series. So these are the distances that I calculate and I put into a series data frame. Okay. So now this thing you can think of like I want to do it for all the points. So for all the points, if I want to calculate the distance, so here what I did was like a very time consuming thing. Like I calculated the distances and then I determine which is the smallest one. So that thing can be done very easily. Once you calculate the distance, you have to put it into a list or this particular frame, and then what you can write is you can write a single line in Python, and that is by using the apply function. So we have seen in k-means also, where you have to apply the same thing over the other rows, or for other points we can basically use apply. And here I'm writing a lambda construct. So in lambda construct, what I'm doing is I'm calling the minimum of the x distance and the distance to, that is from the x. Okay, so by this what I get is I'll get the minimum distance from distance 1 and distance 2. So for all the points you first have the a values, then you calculate the distance 1, the distance 2, and so distance 2 is like since this is from C1, so we are finding the distance of C1 to C2, C1 to C3. So distance 1 and distance 2 for this particular point, that is with respect to C2 and C3. For this point, that is C3, which belongs to CT cluster, this distance 1 is for C1 and this is for C2. For this one, it is of C1 and C3. So it is interpreted in that way. So your Python, when you write that code, it handles in that way. Okay. But when you calculate, it becomes a little uh, difficult way of calculating this. That's why I've not shown this thing when I used to write this, or I didn't do it on the board, because it becomes very difficult thing for calculating. Even when we get smaller values, or when we get values rounded off, then at the end when you calculate or match with the ground truth, it may not be matching. So those kind of things happen. So it's better to put everything in a Pythonic way. Okay. So now since we have both a values and b values, now we are good to go to apply the silhouette coefficient, now we are calculating for each point. So remember, silhouette coefficient is calculated for the single point, one entire clustering, or for the clusters. So here also we can make use of this apply function, and inside that I can write the lambda construct, lambda statement. So you can make out the lambda construct which is there in Python. It has a very vast application when you have such kind of large data sets, or when you want to do some activities in a repetitive way, or when it's too complicated to carry out. So here what I'm writing is like, this is nothing but my formula, b minus a upon max of a and b. Okay, so when I run this, I get the silhouette values for each of the points. Okay, so this is how it basically looks like. Okay, so the same thing I have done on paper, and this is how my values which I got, that is 0.643. Okay, then the average 0.22, 0.24. So those are the clustered values, not the individual values. So in order to find the average silhouette coefficient for points in the cluster, so this values which I found here, that is with respect to the cluster. So you can see cluster marker 0, marker x, and 3, that is c1, c2, and c3. You get in this way. So that thing how you do, so you basically group by with the help of cluster. So you have to calculate silhouette for each of the cluster, so you will group by the thing with the help of clusters c1, c2, and c3. So that is nothing but this group by, and for that you have to calculate the mean, so that you get from the aggregate functions. Okay, and this value you get as here. So this is what I obtain here, that is 0.643, 0.2269, and 0.240. Okay, so you can obtain this value only after you compute silhouette for each of the points. Okay, so you have to calculate the silhouette for each of the points, then you have to calculate the silhouette for the cluster, individual clusters. Now imagine for the whole clustering, now these three clusters are put inside one particular clustering. So there you have to calculate the average of all. So now here that is done for this portion. So this we take sill of sill, that is this one, to the entire thing we call the silhouette, and we calculate the mean. Okay, same thing as of to here. Okay, and we just round off to only three values. Okay, so np dot round will have this operation, that is will calculate the mean, and to how many decimals we have to keep this. So if we keep it as for 5, you'll get the values in this way. So it will not round off. If you want to round it off, it will be 0.316. So this is how we do the silhouette coefficient calculation, and this is how difficult it is to do it on paper. But in Python, you can uh, basically use this functions and this constructs, by which it is very easy for calculating the silhouette values for the points, whether it's for the cluster or for the entire clustering. So well, that's all regarding the example of the silhouette coefficient and a small implementation in Python. So if you found this video helpful and informative, educative, please do like, share, comment, and if you are watching this video for the first time, please hit the subscribe button, and thank you very much for watching this video.